So lesson 7 in chapter 10 talks about theoretical and experimental probability. At the top it says, in a uniform probability model, each outcome has an equal probability of occurring. This would be a uniform probability model because each color is the same size. If a section for the red was maybe smaller than the section for the green, that would not be a uniform probability because one part would have a higher chance of happening than the other. So it says, for example, some carnival games involve spinning a wheel to win a prize. If each prize is equally likely, you can use a uniform probability model to calculate your chances of winning a particular prize. Two things that we are talking about today for probability is theoretical probability and experimental probability. Theoretical probability is based on a uniform probability. It's what should occur when conducting a probability experiment. Experimental probability is based on relative frequency of what actually should occur. If the number of trials is very small, there can be a big difference between the theoretical and the experimental. Okay? So, theoretically, spinning a green should be 1/4. There's one green section out of 4. If I'm going to spin it 4 times, blue, red, green, green. I got this one 2 out of 4 times. So theoretically, what should occur is I should have gotten it once out of 4. Because out of 4 times, I should have gotten each one once. What actually happened experimentally was I got 2 out of 4. Okay? Now, I got lucky and I got green twice. I could spin 4 more times and maybe I don't land on green at all and I'm unlucky. So that's where this is talking about the more trials you do, it kind of averages out when you're lucky and when you're unlucky, and the experimental probability should get closer to the theoretical probability. They should get closer together as you do more trials. Okay? Theoretical probability of rolling a 5 is 1 out of 5. I'm sorry, 1 out of 6. Oh goodness. 1 out of 6. There are 6 different sides. There's one side with a 5. So if I try rolling it 6 times, I got a 5, 2, let me write these down so we don't forget. 5, 2, 6, 3, 5, and 6. Okay? So again, remember the theoretical probability of rolling a 5 was 1 out of 6. I rolled a 5 2 out of 6 times. So my theoretical was 1 out of 6. My experimental was 2 out of 6, or 1/3. This one could be if I flip the coin or the counter, my theoretical of getting red is 1 out of 2. But if I flip it, that was yellow, red, red, red. So again, my theoretical was 1 out of 2. My experimental was 3 out of 4. So this should happen 50% of the time. When I tried it, it actually happened 75% of the time. Again, the more trials I do, the more this is going to even out. I'm eventually going to start getting some yellows again, and it'll even out the more I do this. Okay? So, example 1 says, the table shows the results of an experiment in which a number was rolled. Find the experimental probability of rolling a 6 for this experiment. So, when I look at this, this has that rolling a 1 happened 4 times, rolling a 2 happened 6 times, rolling a 3 happened 2 times, rolling a 4 8 times, rolling a 5 3 times, and rolling a 6 6 times. The tallies were kept as we were actually rolling them. So like they would roll, get a number, and put their line down. Then at the end of all of their times rolling, that's when they marked up, okay, this was 4 times and 6 times and 2 times and so on. Okay. So when you look at this, the experimental probability of rolling a 6, well, I rolled a 6 6 times. Out of a total, if you add up all of these, how many times they occurred, they rolled 29 times. So our probability would be 6 out of 29. When you round, that's going to be about 21%. That's what actually happened when we rolled the dice. Theoretical is when you're thinking about it. Experiments when you're doing it. Theoretical is when you're thinking about it. When I think about it, I should get a 6 1 out of 6 times. When I round, that's about 17%. When they ask you to compare that then, I said rolling a 6 in the experiment occurred more often than expected, because it happened 21% of the time when we expected it should have happened about 17% of the time. Okay? Next one says find the experimental probability of rolling a 4 for the experiment above. Well, it happened 8 times out of that 29 times. That's going to be about 28%. Okay. Again, rolling a 4, there's only one 4 out of 6 different sides, so it would be 1 out of 6. We already know from the last problem that's about 17%. So our experimental is what actually happened. Our theoretical is just thinking about that object. One of the biggest mistakes that I see is people think that the theoretical and the experimental have to be out of the same number. Sometimes they are. Remember, when we were rolling the dice, there were 6 sides and I rolled 6 times, so they happen to be out of the same. Here, there were 2 sides total, and I flipped it 4 times, so they are not out of the same bottom number. So here, remember, it's always how many total times you did it. This is how many total outcomes there are for the object you're using. Okay? And then it says compare the theoretical to the experimental. Well, what actually happened was higher than what should have happened. So we rolled 4 more than we should have, or more than we would have expected to. Okay? The next one says the table shows the results of a survey that asked 200 teens what they would be doing if they were not online. Of a similar group of 450 teens, predict how many would listen to music. So what this is going to do is this going to take your experimental probability, so take that experimental probability and make a prediction based off of that. So when I look, my experimental probability is what I got from my responses for what they would be doing if they were not online. They want to know about listening to music. So listening to music, that's 52, and they said they asked a total of 200. So 52 out of 200 said that they would be listening to music. But I don't want it to be out of 200. I want it to be out of 450. So if this is experimentally what happened, I'm going to use this to make a prediction to figure out how many would that be out of 450. What would I expect for this to happen? Okay, so 200 times x is 200x. 52 times 450 is 2,300, or 23,400. Divide by my coefficient on both sides. and I find that it would be 117 teens that I would expect to be listening to music. Now, I did it slightly different than they did. They took their 52 out of 200 and they simplified it first, and they did it 26 out of 100 for their percent. Okay? Either way, 26 over 100 is the same thing as 52 over 200. It's just that 52 divided by 2 is 26, 200 divided by 2 is 100. So they are equal fractions. So either way works. If you want to simplify first, go ahead. If you want to just use the numbers as they are and simplify at the end if you need to, you can. But by doing this process, it will kind of simplify for you. The next one says, out of 450 teens surveyed, how many would you expect to say that they would be writing or drawing? So again, from the experiment that we did, our probability was that for writing or drawing, that would be 10 out of a total of 200. That's experimentally what happened. We want to know how many would that be out of 450. What could we expect for our prediction? Well, if I do my cross products again, 200 times x is 200x. 10 times 450 is 4,500. Divide both sides by that coefficient, and I would end up getting 22.5. Now, we are talking about people. You cannot have half of a person, so we're going to round that and say about 23 teens is how many I would expect to say that they like to write or draw. Okay? If you have any questions on this, let me know.